So we're going to try out a couple of these practice problems here. They are on the worksheet that is linked to this post. One thing we got to remember is that we are given directions in a word problem that indicates the sign in front of our number. My recommendation to you, I don't really use the guess method, but I would recommend writing out your variables and what it is that you have, and that would be I think a way that you can approach these problems with some success. So let's take a look at number 2, because number 2 indicates that we're moving to the left. A car is moving left at 8 meters per second. It accelerates to the left at 3 meters per second squared for 5 seconds. What is the displacement of the car? So if you recall our equation that we're going to be working with, and we can write that a number of ways. If you remember, we said that x final is equal to x initial plus v naught t plus 1/2 at squared. Those are both the same equation, just written a little bit differently. So if the car is accelerating to the left at 8 meters per second, its initial velocity is negative 8 meters per second. Because it's accelerating to the left, we need to have that negative sign in there. It accelerates to the left at negative 3 meters per second squared, so again, acceleration is negative 3 meters per second squared. And what we know about this is that since the sign of the velocity and the sign of the acceleration are the same, then it is indeed speeding up. When we're also given a time of 5 seconds, we're looking at what is the delta x, or what is the displacement. Notice the variable that we do not have is the final velocity. So we have to cross that one off, and we're going to use our final velocity equation, which indeed is this one written here, what we're going to be focusing in on. So all we have to do is take and plug our variables in at each location, and we can then solve for what that displacement is. So the displacement is equal to the initial velocity, which is negative 8 meters per second, times time, which again is that 5 seconds, plus 1/2 times that acceleration, which is negative 3 meters per second squared, times the 5 seconds squared. So make sure you're only squaring the 5. You're not taking 1/2 times 3 times 5 and then squaring that whole value. And that final answer you'll get from that calculation. We're going to go ahead and move down now to problem number 6. And again, we're just simply using the variables that were given. A wagon is pulled to the left at 0.8 meters per second. There's our initial velocity to the left, so 0.8 meters per second. If the wagon is accelerated to the left at 0.4 meters per second squared, for a time of 6 seconds, what will the velocity be? So we're looking for that final velocity. What are we not given in this case? Well, we're not given the displacement. So that means we're going to be using our no displacement equation, which is what you're seeing there just above Vf equals V naught plus At. That's this right here. And so we can simply just go ahead and plug those values in as well. Our final velocity, again, is what we're looking for. The initial velocity, negative 0.8 meters per second, plus an acceleration of negative 0.4 times 6 seconds. What we tend to find students not necessarily missing questions on the math for these kinematics, but it's failing to put the sign in the correct location. So what we want you to do through these this worksheet and the ones that are attached is to give it a shot, try it out, and see your instructor if you have any questions.